Assalamu alaikum and good day dear students. Hope you all are fine. Welcome to the YouTube channel of Multan Public School and College. This is O Levels 8 Biology 5090 and I'm your teacher Zunera Nadeem. Today we are going to discuss a new topic, that is effect of temperature and pH on enzymes activity. By the end of this video, you will be able to know that what is optimum temperature and pH, what is denaturation of enzymes, and what is the effect of temperature and pH on enzyme activity. As in the previous video, we have discussed that what are enzymes and what is the role of enzyme as a biological catalyst. So before discussing the effect of temperature and pH on enzymes activity, I will again tell you that what are enzymes. Enzymes are biological catalysts that are made up of proteins. They alter the rate of chemical reactions without themselves being chemically changed at the end of a reaction. There are different factors which affect the activity of an enzyme. But two major factors which affect enzyme activity are temperature and pH. Slightly change in their values can affect the activity of an enzyme. We will discuss the effect of temperature on the activity of an enzyme. Slightly change in the temperature will automatically affect the rate of enzyme action. Enzymes usually perform their best at their optimum temperature. They are inactive at very low temperature. With the increase in temperature, the activity of an enzyme increases. For example, digestive enzymes can digest the same amount of food in shorter period of time when it is given a higher temperature. But same enzyme can digest the same amount of food in longer period of time at a lower temperature. As I have told you that enzymes perform their best at their optimum temperature. So now, what is an optimum temperature? Every enzyme shows highest activity at a specific temperature. That temperature is called their optimum temperature. The action of an enzyme above or below this optimum temperature is slower. When we look at the range of most of the enzymes for this optimum temperature, so that is between 40 to 45 degrees Celsius. With every 10 centigrade rise in temperature, the activity of enzyme becomes twice until they reach their optimum temperature. But beyond this optimum temperature, the activity of an enzyme starts decreasing, and at a point reach that they become denatured. But the optimum temperature of different enzymes is different. As you can see in the graph that with every 10 centigrade rise in the temperature, the activity of an enzyme is twice. And at 40 centigrade, it reached its highest point because 40 centigrade is optimum temperature for this enzyme. But after this temperature, the activity of an enzyme starts decreasing. And at one point, as you can see on 60 centigrade, this enzyme becomes completely denatured. As I have told you that beyond optimum temperature, every enzyme loses its activity and its activity starts decreasing. And after a certain time, that enzyme completely becomes denatured. So now what is denaturation As we all know that enzyme is a protein, and when it gains high temperature, it loses its shape. As a result, it loses its catalytic activity. Why? Because after losing the shape, that enzyme becomes denatured. As you can see in the picture, that when heat above 40 centigrade is given to the enzyme, this enzyme loses its shape. The active site of the enzyme changes shape, and now this active site can no longer bind to the substrate. That's why it loses its catalytic activity. Now this enzyme is completely denatured. First, we have seen the effect of temperature on the activity of an enzyme. Now we will see that how pH will affect the activity of an enzyme. Just like temperature, enzymes are also affected by changes in pH. The activity of an enzyme reached its highest point when it received its optimum pH. Optimum pH is that point where the enzyme is most active. Just like temperature, extremely high or low pH values generally result in complete loss of activity for most enzymes. Enzymes are also affected by the acidity or alkalinity of the solutions on which they are acting. You can see in the graph also that when the activity of an enzyme reached its optimum pH, after that the activity of this enzyme start decreasing, and after a certain time, at a point, the activity of this enzyme stops. Discussing the effect of pH on the activity of an enzyme. So what is pH? The acidity or alkalinity of any solution is measured by a value. That value is known as pH. The neutral point, that is 7. For example, like in pure water, when any solution has pH 7, that solution is known as neutral solution. If a solution has a pH value above 7, that solution will be alkaline. And if the solution has a pH value below 7, that solution is acidic. As the solution becomes acidic or alkaline, activity of enzyme decreases. For example, at pH 4 or 9, amylase is completely denatured. Just like temperature, different enzymes have different optimum pH also. You can also see in this graph, which is showing that different enzymes have different optimum pH, and at that optimum pH, that enzyme is most active. We have discussed the effect of temperature and pH on the activity of an enzyme. Just like temperature and pH, substrate concentration also affect the rate of reaction. As I have told you in the previous video that what is a substrate? Substrate is that molecule which will bind with enzyme and form a complex. As a result, a product will be formed. So, increasing substrate concentration increases the rate of reaction. This is because more substrate molecules will be colliding or binding with enzyme molecules, so more product will be formed. But after a certain concentration, any increase will have no effect on the rate of reaction, since substrate concentration will no longer be the limiting factor. The enzymes now will actively become saturated and will be working at their maximum possible rate. So now what is a limiting factor? Any factor that directly affects the rate at which a chemical reaction occurs, if its quantity is changed, it is called a limiting factor. The value of this factor has to be increased in order to increase the rate of the process. Look at these graphs. These graphs are showing that increased substrate concentration leads to increased rate of reaction, because when more substrate will bind with enzymes, more products will be formed. But after a certain point, this increase in substrate concentration will no longer affect the rate of reaction, because now all enzymes are working at their maximum rate. Sometimes enzyme also need coenzyme to perform its activity or to catalyze a reaction. A coenzyme is an organic non-protein compound that binds with an enzyme to catalyze a reaction. These coenzymes cannot by themselves catalyze a reaction, but they can help enzymes to do so. Most coenzymes have vitamins or vitamin derivatives, especially B complex vitamins, as their essential components. So this was your whole topic. Hope all the things are clear to all of you. Thank you. Allah Hafiz.